Okay, are you ready for an epic fight between two prehistoric predators? Well, hang on. Look at this creature. You know it. An ancient shark about 65 feet long that used to swim through the dark waters of the world's oceans and was so terrifying it had no enemies. Well, almost. Scientists have recently discovered the remains of another ancient predatory fish off the coast of Australia, a fish that lived around the same time as Megalodon. It was small, about the size of a dolphin, but it could pose a danger to the infamous shark. How is it possible if this creature was many times smaller? Well, let's take a look. This monster is called Janjucetus, and technically it wasn't exactly a fish. It was a distant relative of the modern baleen whale. Outwardly, it may seem quite cute, similar to that baleen whale I mentioned, but you wouldn't want to meet it in the ocean. It had the massive skull of a whale, large eyes the size of tennis balls, and a short snout with an immensely powerful jaw filled with razor-sharp teeth. In other words, it was like a shark version of the baleen whale. Janjucetus lived during an ancient period called the Oligocene, which was about 33 to 23 million years ago. At that time, there was an incredible abundance of life in the world's waters. Giant penguins, small whales, sharks 2 to 3 times larger than modern ones, primitive dolphin species, and many other unusual creatures. Now imagine that in this ancient and terrifying neighborhood, a giant Megalodon met a Janjucetus. At first sight, it's not love. The Megalodon's victory is obvious, but don't rush to write the Janjucetus off. It's agile and fast. It's quite possible that it was more mobile than Megalodon, and during the fight, it would have avoided a direct attack. The Megalodon would have lost sight of such a small opponent, while the Janjucetus would have swum up to the shark's belly and opened its jaws. They're small, but there are a lot of sharp teeth. Now, these teeth were designed to rip and cut. The Janjucetus would attack the Megalodon with a small but very unpleasant bite, and the shark would have swum away after such a punch. But who knows? Maybe Megalodon would have immediately eaten Janjucetus in the first seconds of the fight. Megalodon could have won, but in terms of speed and mobility, it would have lost. So let's look at something bigger, something that could actually have competed with Megalodon. It doesn't have to be a monster living at the same time as the ancient shark. We can make our own rules. Imagine that all ancient marine creatures ended up in the same pool with Megalodon. So its next opponent is the Liopleurodon. Now initially scientists thought that this monster could grow to be 82 feet long, which is even larger than Megalodon. But more accurate studies have shown that it only reached 32 feet, which is about the size of a modern orca. The Liopleurodon lived in the waters of Western Europe around 160 to 155 million years ago and shared territory with other dangerous reptiles such as ichthyosaurs and plesiosaurs. Yes, it was smaller than them, but it had one big advantage. The Liopleurodon possessed one of the largest jaws in the animal kingdom, which accounted for about 20% of the total length of its entire body. That's a mouth. Its jaws were about 6.5 feet long. A huge, toothy mouth the size of an adult basketball player filled with smooth and dagger-sharp teeth, ideal for cutting steaks and peeling ammonite shells. And by the way, scientists suspect that ammonites and squid were the creature's main diet. This super predator was also a very fast and agile creature that ambushed and attacked its prey from below. Megalodon would have been in big trouble. The grip strength of a Liopleurodon would surely be more powerful than that of Megalodon. Besides, the Liopleurodon's size and mobility would allow it to attack the enemy from different sides. It's probably why Megalodon would have lost in that fight. The next opponent for our Megalodon is the Dunkleosteus, and to be honest, this guy has almost no chance of defeating the large ancient shark. But the Megalodon probably wouldn't have beaten it either. The Dunkleosteus was one of the earliest predators of the ocean. It lived in the late Devonian, about 382 to 358 million years ago. Its size was about 13 to 32 feet or even less, and it also had no teeth. What? A predator without teeth? How did it survive in a dangerous prehistoric world? Well, it grabbed and chewed food with the help of special jaw growths. Those growths were so powerful that they could pierce steel, if there was any around. In a sense, these were not teeth, but bones. Okay, let's say the Megalodon grabbed this predator by the belly and it couldn't do anything with its growths. But the problem is that the Megalodon would have hardly done anything either, because the Dunkleosteus was a heavily armored fish. Just look at the shell. It probably limited its mobility, but it provided incredible protection. This monster felt like a big stone in the teeth of the Megalodon. It's unlikely that the Megalodon would have wanted to chew this stone. It would have spit it out, and both predators would have gone about their business. We've got a draw here. And now, the final match. Here's the next opponent. You see anything? Is this enemy invisible? What's happening? Ah, there it is. Meet the Telemonstrum. It's a tiny ancient monster, just 11 inches long. Huh? What can it do to a giant shark? Next to the Megalodon, the Telemonstrum is like a box of matches compared to a human. But if the Megalodon had had a developed brain, like people do, it would have been very scared of this creature and would have immediately swum away. Many people scream and run away in fear when they see a creepy insect crawling or flying, or when a mouse runs across the floor. Some of us jump on the couch in horror. Not all of us, but some. The Megalodon would have jumped out of the water like a dolphin if the Telemonstrum had charged at it. Just check it out. It looks like an underwater bike with a long trunk with a jaw at the end. And these handlebars, where you would put your hands to control your bike, are the eyes. It's like the eyes of a hammerhead fish, only thinner and longer. The body of a squid, cuttlefish fins, snail eyes, and a toothed proboscis. This is a horror movie character. Scientists say it probably hunted jellyfish, small fish, and shrimp. And it didn't chew the food, it licked it like ice cream. Obviously, it's not an opponent for the Megalodon, but it's still a creepy monster. Well, what would have happened had it really started a fight with the Megalodon? It would have been difficult for the ancient shark to find it. It would have been unlikely to catch this tiny monster in the mouth, and the Telemonstrum wouldn't have been able to do anything to the Megalodon either. However, I can think of one strategy. The creepy creature had a long trunk. What if it had just swum under the Megalodon's fin and started licking it? If the shark had felt the tickles, then it would probably have worked. But most likely, they wouldn't have fought each other. It seems like they would have made perfect friends. The Telemonstrum lived about 300 million years ago in shallow seas and estuaries that covered the territory of the U.S. When scientists discovered this creature in 1955, they were shocked because no one had any idea what it was. Experts compared it to worms, tunicates, conodonts, mollusks, and vertebrates. And do you know who it really was? Well, scientists still have no idea. They can't determine its place on the tree of evolution. Perhaps this is some new branch, and its descendants simply haven't survived to this day. The Megalodon was one of the most dangerous predators on Earth. But now we know that other equally scary monsters lived in the oceans. But what if the Megalodon lived today? Who could have defeated him? A blue whale who would be even bigger than this ancient shark. But the blue whale seems to be a kind animal. It wouldn't fight. How about the Kraken? The Kraken versus the Megalodon? Well, let's save this fight for another video.
Thanks to sci-fi, we usually imagine extraterrestrials as smart beings with huge heads walking on two legs. But if life really exists out there, it could look like, well, anything. From an upside-down nightmare to a weird water creature looking like it was drawn by a toddler. But we don't need to travel across the universe, just back in time. Because a long time ago, Earth already had a creature like that. This is the story of the Tully monster, one of the most bizarre creatures that scientists still can't explain. Around 310 million years ago, Earth was a drastically different place. Today, our continents are scattered like pieces of a broken plate, but back then, during the Carboniferous period, the planet had one supercontinent, Pangaea. That was more than 200 million years before a T-Rex was chasing down a Triceratops. Huge areas were covered in warm, shallow seas and swampy coastlines, with thicker air and higher oxygen levels. Oceans were filled with creatures that never made it past evolution's experimental phase. like this little guy. At one point, the area that's now Illinois was just shallow coastal waters and muddy shores. Sediment from rivers often buried marine creatures, and sometimes trapped them in iron-rich nodules before they could rot away. That's how soft-bodied animals, which usually don't leave fossils, were preserved in detail at a spot known as Mason Creek. Every single Tully monster fossil we know of comes from this one place. It's entirely possible that these strange creatures were swimming all over the prehistoric world, but this could be the only graveyard that had the needed chemistry to preserve their bodies until we found them. But wait, what exactly is this thing? Well, first off, it was named after Francis Tully, the Illinois fossil collector who first found it and brought it to scientists. And second, it wasn't a monster, that's for sure. The animal was pretty small, usually only about 3 to 14 inches long. It had a soft, swimming torso shaped like a thick worm or a slug without any hard shells or bones. But its front end was both the coolest and the weirdest part. It had a long, flexible nozzle sticking out of its face, almost like a vacuum hose, except at the end of that hose was something resembling a claw. The snout itself wasn't rigid, it could extend and bend, similar to how an elephant uses its trunk, or how an octopus reaches with an arm. So instead of biting prey directly, it probably reached out with its face tentacle, grabbed a snack, and pulled it in. Its eyes were another weird, one-of-a-kind feature. They were positioned on a stiff horizontal bar extending from its head, with one eye at each end. This setup gave it a wild field of view, similar to how a periscope or side-mounted cameras can help you see more. Most animals fall into two groups, vertebrates and invertebrates. Vertebrates have a backbone like fish, dinosaurs, dogs, and us humans. Invertebrates don't, like worms, snails, and insects. The Tully monster is one of the rare cases where scientists still argue what it was. When scientists look at the fossils, they see a pale stripe running down the middle of the body. One group says that's just a gut line, which would put the Tully monster in the squishy invertebrate camp, meaning it was a weird swimming slug. But another group claims that it was a notochord, a kind of primitive stiffening rod that evolves into a spine. If they're right, that would make the creature a vertebrate, a distant cousin of fish and even us. Basically, all of this makes the Tully monster a mix of a fish, a worm, and a crab, something never found since. Based on that soft, squishy body and little stabilizer fins, we know the Tully monster wasn't exactly racing other fish. It wasn't fast like a shark. It was more of a slow-motion cruiser. It probably drifted through the water using that long snout to poke around in the mud for jellyfish, sea cucumbers, or maybe even some rotting stuff. Despite its scary-looking claw and eyes, we can't tell for sure if it was a predator. The Tully monster was pretty well adjusted, so we don't know why it went away. If we look at the fossil record, this creature had disappeared way before the massive extinction events wiped out the dinosaurs or the earlier marine life. There wasn't an asteroid or a volcano involved. Perhaps it vanished because its home wasn't the same anymore. Remember, the Carboniferous period was a wet, swampy world. But as time went on, Earth's climate shifted. Tropical estuaries dried up and the chemistry of the water changed. This probably caused Tully's specific playground to disappear. As far as we know, the monster left no genetic heir. Usually, if an animal goes extinct, it leaves behind a cousin or a descendant that evolves into something else. Dinosaurs left us birds. Ancient fish left us, well, modern fish. But the Tully monster remains unique. There's nothing alive today that looks remotely like it. And that's exactly why scientists are still pulling their hair out trying to classify it. We aren't confused because we're missing the pieces. In fact, we have over 2,000 fossils. We're confused because we have nothing to compare it to. And who knows, oceans are largely unexplored, so we might run into some new creature eventually that will add new pieces to the evolutionary puzzle. The Tully monster might be the captain among the weird prehistoric swimmers, but it definitely wasn't alone. If we look back at the fossil record, especially during the Cambrian and Permian periods, we'll find a whole gallery of evolutionary experiments that look like they were designed by a committee of ETs. For example, we had hallucigenia, our upside-down creature. When scientists first found fossils of this tiny worm-like creature, they didn't know which side was up. On one side of its body, they saw long, sharp spines. On the other, they saw soft, stubby protrusions. They assumed the tough parts were legs and the soft protrusions were tentacles on the animal's back. Years later, better fossils revealed it was actually the other way around. The whole animal was put together upside down. The spines were like defensive spikes sticking up, and the softer parts were actually short legs meant to touch the ground. In other words, it wasn't walking on stilts at all. It had been upside down the whole time. Then there was Opabinia. This thing looks like a shrimp that got extremely confused. Most animals are happy with 2 eyes. Spiders have 8, but Opabinia decided it needed 5 for some reason. 5 mushroom-shaped eyes found out on its head, giving it a 360-degree view of the world. And if that wasn't enough, it had a long, flexible nozzle sticking out of its face, kind of like that of the Tully monster. When this animal was first presented at a science conference in the 1970s, the room actually erupted in laughter because everyone thought it was a practical joke. Finally, there was a creature called Helicoprion. At first glance, it looks like a shark. But look at the mouth. Instead of a normal jaw that opens and closes like a hinge, it had something called a tooth whorl. As it grew new teeth, the old ones rotated inward, creating a literal spiral of teeth in its lower jaw. It looked like a circular saw blade embedded in its chin. Scientists spent decades arguing about where this saw blade actually went. Some put it on the nose, some on the tail, until they finally realized it was inside the mouth. All of these creatures, the Tully monster, the upside-down worm, the 5-eyed shrimp, and the buzzsaw shark, remind us of one thing. We think we know what life looks like, but the history of our own planet proves that biology can be stranger than any sci-fi movie. We shouldn't assume evolution follows a straight line toward normal animals like us. Sometimes it takes a detour into the Twilight Zone. In 2021, while drilling about 11 feet beneath the surface of permafrost in northeastern Siberia, researchers uncovered a 24,000-year-old frozen life form. And then, they brought it to life. Before cloning it, or better said, it cloned itself. This might sound like the beginning of a sinister horror story, but don't worry, it's actually quite the opposite. What scientists unearthed was a microscopic frozen organism that could fundamentally reshape what we think about evolution and survival. The uncovered tiny creatures are called bedelloid rotifers, microscopic animals with little wheel-like mouths that they use both for moving and feeding. They were first discovered in 1696 and are fairly common in freshwater environments around the world, with a few saltwater species. They might seem unremarkable, but scientists have been studying them since early microscopes made it possible to actually see them. Because even though there are only a few dozen microns wide, they're surprisingly complex, with brains, guts, muscles, and reproductive systems. Could it be that within that complexity lies the secret to ultimate resilience, maybe even for us humans? Let's break it down. These creatures are extremophiles. That means they can survive being completely drained of water at any point in their life cycle, then lie dormant until rehydrated. But that's not all. They can also persevere through some of the harshest conditions on Earth, or in outer space, or even being stuck in the Siberian permafrost wasteland for tens of thousands of years. This is possible because they can enter cryptobiosis, a condition where organisms pause their metabolism and become nearly inactive. It may sound sciencey, but actually, some of the everyday products we eat are stored in a fridge thanks to this phenomenon. Take yeast, for example. Live yeast cells are surrounded by a protective layer made of dead cells and some nutrients. You can keep yeast at room temperature, But if cryptobiosis comes into play, in the form of your fridge or freezer, it stores much better and longer. During cryptobiosis, rotifers accumulate protective compounds like chaperone proteins, which help them repair and recover once favorable conditions return. Chaperone proteins are like tiny bodyguards. Their job is to keep other proteins in the cell from falling apart under pressure. When the body is stressed, whether from heat, cold, toxins, dehydration, or just the natural aging process, the proteins inside our cells can start to misfold. Proteins need to be folded into very specific shapes to function properly, and when that structure breaks down, they become useless, or worse, harmful. Misfolded proteins can pile up and interfere with normal cell function. In some cases, they clump together in ways that poison the cell. This kind of damage is even linked to serious health conditions. So, if rotifers have developed powerful proteins that prevent cellular chaos even under extreme conditions, could we use them to protect human cells from diseases and aging? By analyzing the age of the ice they were found in, scientists figured out that these frozen rotifers were at least 24,000 years old. That's a huge leap from earlier studies, which showed they could survive frozen for only about 10 years. Now that's what you call record-breaking. This period of Earth's history is known as the Late Pleistocene Epoch, a time dominated by the Ice Age, which means these invertebrates were lying dormant when Manny and Sid were having their adventure while roaming the icy landscapes, along with saber-toothed cats and giant ground sloths. Fun fact: although animated movies like Ice Age show woolly mammoths as huge, towering giants, they were actually about the same size and weight as today's average African elephant. Nature and evolution can be so cruel, yet fascinatingly unpredictable. Massive, menacing beasts that came from the Ice Age couldn't survive it, yet something tiny and weird, like a bdelloid, could. But regarding our unfrozen creature, after the soil thawed, the organism didn't just begin moving again, it also started reproducing. This is thanks to an ability called parthenogenesis, a specific form of reproduction in which embryos develop from unfertilized eggs, allowing them to reproduce independently. It really is like cloning, but it happens naturally. Many organisms, such as certain insects, reptiles, and even some birds, are capable of parthenogenesis, at least under specific conditions. For example, in honeybees, males develop from unfertilized eggs through parthenogenesis, making them genetic copies of their mother. However, parthenogenesis is often seen as an evolutionary disadvantage because it limits genetic diversity, meaning that most species that reproduce this way eventually face extinction. Despite this, bdelloid rotifers have diversified into over 450 distinct species over millions of years, which is extremely rare. Scientists believe their survival comes down to a few evolutionary adaptations. They can pause their metabolism through cryptobiosis, repair their DNA with specialized proteins, and even borrow useful genes from other organisms using a process called horizontal gene transfer. Unlike most animals, which rely solely on inherited DNA, these organisms can steal genetic material from bacteria, fungi, and even plants, splicing foreign genes into their genome to gain new survival traits. Some studies have shown that up to 10% of their active genome comes from foreign DNA. This could explain their extraordinary resilience. They borrow genes for stress resistance, toxin breakdown, or radiation repair, essentially patching and upgrading their DNA in real time. It's not like the Mind Flayer from Stranger Things, where the creature absorbs another organism to improve itself and grow. It's more like a spy stealing a blueprint from a rival lab to learn its secrets. When cells rupture, for example, when bacteria die nearby, bdelloids scoop up loose DNA fragments and integrate them into their own genome. Interestingly, the usual expected lifespan of bdelloid rotifers under normal circumstances is only 2 weeks. The soil sample that contained these rotifers also held nematodes or roundworms, another group of tiny survivors already known to withstand tens of thousands of years icebound. This isn't just limited to microscopic animals. Researchers have successfully regrown Antarctic moss and entire Campion plants from seeds and samples frozen for hundreds or even thousands of years. In 2016, a team of Japanese scientists brought tardigrades, or simply water bears, back to life after 30 years in cryptobiosis. Tardigrades are even more impressive because they can live in a suspended state for up to 30 years, without food or water, and with temperature swings from deep freeze to 300 degrees Fahrenheit. These guys can also endure crushing deep-sea pressures, vacuum, microgravity, and intense radiation of space. Remember when we said earlier that these species can survive the harshest conditions on Earth and beyond? It wasn't an exaggeration, and now you understand why. And it's exactly why NASA and its partners sent water bears and bedeloid rotifers into orbit. They've even been aboard the ISS, helping scientists understand how these animals handle microgravity, radiation, and stress. Not only that, but in 2007, the European Space Agency launched a bunch of tardigrades into low Earth orbit, completely exposed. No suit, no shield, floating in a vacuum. They were blasted by cosmic radiation, UV light 1,000 times stronger than what hits Earth's surface, and temperatures near absolute zero. And when they came back, most of them woke up and reproduced despite the harsh conditions they were exposed to. This ties into an old theory called panspermia, the idea that life didn't originate on Earth but arrived here, locked in space dust or trapped inside a meteorite. Before, maybe it sounded like a fringe science, but when organisms can brush off cosmic radiation, then it doesn't seem so far-fetched, does it? What about humans? Does this mean we now fully understand the way hibernation works and are close to putting humans in this state? Sorry for spoiling it for you, but it still feels more like science fiction. However, researching rotifers, water bears, and similar organisms can lead to massive breakthroughs in other fields. Their resilience might be a blueprint for medicine, for reshaping what it means to age, maybe even to pause life itself, or extend it. We're talking real, practical innovations, from better preservation of human organs for transplantation to drugs that slow aging at the cellular level. And yes, maybe even cryogenic hibernation, long enough to make interstellar travel possible.
Now, you can't find living dinosaurs nowadays, which is a good thing, mostly, but you can still meet some creatures that might have gone to lunch with them. The frilled shark, for example, is a living fossil that comes from a family of sharks that have been around for about 80 million years. One of the coolest things about it is its long, eel-like body that can grow as long as 6 feet. It has 6 pairs of gills on its throat, which help the frilled shark breathe in the deep, cold ocean where there isn't much oxygen. The shark can move very quickly, like a snake, to catch its prey when it least expects it. Little frilled sharks take an exceptionally long time to grow, up to 3.5 years, which is one of the longest times for any animal with a backbone. The Chinese giant salamander is another living fossil that can tell you what was going on Earth around 170 million years ago. Now, when I say tell, I really mean it, as it can make sounds like hisses, whistles, and barks, and even a noise that sounds like a crying kid. The biggest Chinese salamander found so far weighed 130 pounds, as heavy as 2 Dalmatians, and was almost 6 feet long. Giant salamanders like to be alone. Hey, I want to be alone, and will chase away other salamanders from their space, except when it's time to start a family. During the day, they hide and sleep under rocks. They can make a special substance from their skin that keeps predators away. Now, gharials are reptiles that have been around for about 38 million years. They live in India and Nepal in slow-moving, muddy rivers. Sadly, there are very few gharials left in the wild, less than 100. These creatures can't control their body temperature, so they need to sunbathe to get warm or cool down in the water if they get too hot. Their eyes are close together and face forward, which helps them see in 3 dimensions and judge distances more accurately. Gharials also have a transparent third eyelid that protects their eyes when they're underwater. They have over 100 sharp teeth, but they can't chew their food. Instead, they use their strong jaws to grab prey and then, swallow it whole. The alligator gar is a fish that has a family history of more than 100 million years. It still has some cool features from ancient times, like being able to breathe both air and water. It also has a special spiral-shaped intestine, like a shark. The alligator gar is one of the biggest and heaviest fish in North America. Just like an alligator, it has a long body and snout, plus a row of sharp teeth. But instead of legs, the gar has fins to help it swim underwater. The tuatara isn't a lizard as you might think, and isn't a dinosaur either. This New Zealand resident is one of the most unique animals in the world. Scientists love studying tuataras because they can help us understand how today's lizards and snakes evolved. One of the coolest things about the tuatara is its third eye, called a parietal eye, on its head. It has its own lens, retina, and a nerve that connects it to the brain. Scientists think it might help the tuatara know when it's light or dark outside and absorb sunlight to make vitamin D or help them keep their body temperature exactly right. Tuataras can live an extraordinarily long time, up to 100 years. Cassowaries are the youngsters on our list, as they've been around for only 60 million years. They have some things in common with dinosaurs, like their 3-toed feet and how they breathe. Cassowaries love to eat fruit, lots and lots of fruit. This love of fruit helps the rainforest because when cassowaries eat the fruit, their bodies don't harm the seeds inside. As they move around the forest, they spread these seeds, you can guess how, with their own natural fertilizer, helping new plants grow. Cassowaries are big birds, about 6 feet tall and weigh over 100 pounds. They have a special claw on each foot that is 5 inches long, and they can use it to kick real fast. If they feel threatened, they can charge, kick, and even jump on someone. They can also leap up to 5 feet in the air. So, the best thing to do is stay far, far away from where they live. The order Notostraca is a group of crustaceans that you may know as tadpole shrimp or shield shrimps. These animals have been around for about 360 million years. They have a wide, flat shell that covers their head, and they have a pair of eyes on top. These creatures can be found all over the world in different kinds of water, like freshwater, brackish water, and even salty pools. They can also look different depending on where they live. Notostracans aren't picky eaters and can snack on pretty much anything, from plants to small animals and other shrimps. Some of them are considered pests in places like California rice paddies because they stir up the mud, which blocks sunlight from reaching the young rice plants. Sturgeons are some of the largest fish species on the planet. They live only in the cool waters of the northern hemisphere and never travel below the equator. Even though they are huge, sturgeons don't have teeth. They eat by sucking food off the bottom of rivers, gulfs, lakes, and oceans. Scientists believe that sturgeons came from a group of fish that first appeared around 419 million years ago, long before dinosaurs even existed. Their ancestors survived a big extinction event that wiped out 90% of all species and went on to become the largest fish in many rivers in North America and Eurasia. Sturgeons can live up to 100 years old or even older. Female sturgeons can lay up to 3 million eggs at a time, but not all of the eggs eventually turn into real fish. Our next hero, the Pacific lamprey, has successfully lived through at least 4 mass extinctions. Its ancient ancestors evolved over 450 million years ago. These creatures have cartilage instead of bones and a third eye, which is a special light-sensing organ on top of their heads. Instead of a regular jaw, they have a mouth surrounded by teeth. They latch onto prey and sup up body fluids like real underwater vampires. And although he wasn't living underwater, the story goes that King Henry I of England might have lost his life because of a lamprey. The English monarch loved this fish so much that he defied doctors' orders to stop eating its flesh. He got sick every time he'd have it, but the lack of bones and the unusual taste made the royal fall in love with it. As a result, he got some scary symptoms from eating lamprey and eventually passed away. Can you say clueless? The elephant fish, also called the Australian ghost shark, has been on Earth for around 400 million years. Even though they're related to sharks, they aren't actually sharks. Instead of bones, their bodies are made entirely of cartilage. These fish have a special shiny tissue in their eyes that can make their eyes look like they change color from yellow to green. Elephant fish can be pretty tough and will fight back if they feel threatened. They like to be alone and usually don't hang out with other fish. Horseshoe crabs also deserve the title of survival champs, as they've been around even before dinosaurs, since 450 million years ago. 4 species are still roaming the ocean from Maine all the way to Mexico. Horseshoe crabs are more like spiders than ticks than they are like real crabs. They have 9 eyes, plus extra light sensors near their tails, so they can see really well. They breathe underwater using flap-like gills near their belly, and sometimes they use these gills to swim upside down. Every spring, when the tide is high, these creatures come up to the beach at night to mate and lay their eggs, and you can see hundreds of thousands of them. Well, you can toss out those chocolate frogs from Harry Potter. We have real ones now. Well, they certainly wouldn't taste as good since they only got that nickname because of their skin, which is the color of milk chocolate. These frogs live in the swamps of New Guinea, but they're close cousins of green tree frogs common for northern and eastern Australia. Now, Australia and New Guinea were connected by a land bridge a long time ago, so they have similar kinds of animals. This chocolate frog is smaller than its green relative, but both species have the same call for mating, which sounds like a deep, rasping bark they repeat in long series, which I won't do here. Local people from a small island in Africa helped scientists find a new kind of Scopes owl. They're probably descended from the first owls that came to this area a long time ago. Although they come in assorted colors, they're mostly brownish, which is why they easily blend in with trees, so you hardly even see them. They're also really small, and they have a call you won't hear anywhere else. It sounds like a short "too" note they repeat fast, as if it's an insect producing this sound. You can hear them making these calls in duets as well once night falls. They might be called endangered species, considering they live in a small area of around 6 square miles, and there are up to 1,500 of them. The Sunda flying lemur is a kind of gliding mammal you can find in Southeast Asia. It has a small head, small ears, and adorable big eyes that help the animal see well in the dark and move at night. This little one is not a real lemur. It falls into a category called Cologos. Even though its name says differently, this creature can't really fly. It can only travel long distances, which is not bad at all, considering it can glide for up to 328 feet without losing too much altitude. Its special skin fold makes it easier to glide between trees, and its lightweight skeleton and webbed feet help as well. This cute animal is small, less than 2 feet long, and it weighs up to 4 pounds. Plus, it can camouflage well because of its dense and mottled fur that resembles tree lichens. So once upon a time, more than 160 million years ago, I wasn't around then, there was a spider that kind of looked like a pelican. As big as a grain of rice, it would sneak around in the leafy areas of our planet and look for prey it could catch with its fanged pincers placed at the end of its long neck. It especially liked to eat other spiders. This tale has a happy conclusion, well, depending on the perspective. These fellows still exist, and they're far more diverse than anyone expected. When it's not going after its prey, the pelican spider just folds its pincers down against its long part like a neck. This makes it look more like a bird than a regular spider, and that's how it got its name in the first place. These creatures are different from most other spiders because they don't make their own webs. Instead, they just look for the trails of silk other spiders left behind in the leaves and follow them. When they find a web some other spider made, they patiently wait for the right time to strike, which is how they got the proper nickname, assassin spiders. So it's not unusual for hermit crabs and sea anemones to team up. Anemones have stinging tentacles, and they use them to protect crabs from predators. In return, they get a free ride to places they haven't seen before and some leftovers crabs share with them. But off the coast of Japan, scientists found this new anemone that does something extra special. Not only does it live on a hermit crab's shell rent-free, but it also creates a covering that goes over the shell. In a way, it adds a porch to the crab's house. It's not something you'll see very often, because most sea anemones don't go to such lengths. Now, what's even cooler is that they won't build these extensions for any crab out there. They have a specific partnership with only one hermit crab species. If a crab wants to move to a new shell, its friend joins it. This type of anemone is called a calcifer, after a character in Howl's Moving Castle. Calcifer is a fire demon bound to the wizard's castle by a magical pact. This castle moves from place to place, like a hermit crab. In 2020, researchers found a very long animal that looked like it was made from gelatin. It happened around 2,000 feet under the surface in a deep canyon off the coast of Western Australia. They were exploring the ocean floor, trying to find signs of life there. They didn't find this creature on purpose. They unexpectedly stumbled upon it as they were heading back to their ship, and it turned out to be a type of deep-sea siphonophore. It's related to the Portuguese man-o'-war, those blue bottles you might see floating on the surface of the ocean. These animals are not a single organism. They're made up of many smaller parts that work together. We call them zooids. Some zooids are there to help with reproduction, while others oversee feeding or moving through the water. These unusual creatures mostly look like twisted and tangled feather boas. Its spiral shape is its hunting technique. The siphonophore has many stinging tentacles that form some type of barrier in the water and trap small animals such as fish and crustaceans. The scientists didn't have much time to examine the creature, but they noticed that it was the longest siphonophore they had ever discovered. It could be longer than a blue whale. Wow! Now, here's a little creature you don't see every day. They're called tree hoppers, and they spend most of their time on plants and trees. They're not longer than a dime, but you can find them in different shapes. Some look like tiny helicopters, while others are more like leaves, thorns, or even raindrops. There's a thing called a pronotum. That's like a small plate other insects have too, and it resembles a shield. Tree hoppers are real artists here because their pronotum gives them these bizarre shapes that make them stand out in the animal kingdom. And since they have such a weird shape, it's easier for them to stay safe from predators. Their barbs and spines warn other animals that tree hoppers might be tough to swallow, so they might not be worth catching. Bright colors are not that attractive either, since they tell predators there might be toxins in the body of their potential prey. Plus, they're good at mimicry, the art of pretending to be something else. Their big pronota are light and hollow, so they can easily fly. They communicate with each other by sending vibrations through plants. You won't hear them making loud sounds like some other insects. Tree hoppers prefer to shake their bodies to produce vibrations we humans can't hear. Interestingly, they use such a form of communication to protect their young. Many other insects just leave their eggs alone, but tree hopper mothers stick around and watch over their eggs. When something dangerous, such as a stink bug, comes closer, a young tree hopper sends out a vibrating signal. Its siblings quickly notice this signal and join in, which is how they make the warning stronger. The mother receives the messages and gets into action. She either buzzes her wings very loudly or uses her back legs to defend her kids from the intruders. They're like mosquitoes in a way. It's just that they use their special mouth parts to pierce not people, but plant stems where they take their juices. Weird and wonderful, all in the same package.